Okay, welcome to today's class. And today's topic is object-oriented programming. And this is an important point in the AB Computer Science A, and it is uh, different from uh, it is some different from what we learned in the Olympiad in informatics. And the and we will. Okay, then we continue, and we will see this object-oriented programming more in designing the uh, common programs instead of algorithms. Okay, then we continue. Uh, what are objects? In computer science, an object can be a variable. Variable is, for example, int x, and in this instance, x is a variable. The data structure. What is data structure? Is an array, array string, data structure. Function. Function is a main, and method, and as such in a value in memory referenced by an identifier. For this variable, the identifier of it is x, and the identifier of this function is main, and we define a reduced string as, and in this instance, as is the identifier. You know? Okay, and let's continue. In the class-based object-oriented program paradigm, object refers to a particular instance of a class, where the object can be a combination of variables, functions, and data structures. So, from this paragraph, we can know that we can include this is a class, and we can include many things, this variable and data structures and functions. We can include these objects into one class or several classes. And so an object class can be a combination of variables, functions, and data structures. An object is an absolute idea, and we will also, and all of objects in Java uh, implement the object class. This object is a class name, and we will talk about it later. Classes. We've talked before that we can include objects into classes. class and object here, class object object, and they can have different types and different names, identifiers. Okay, this is an example of class using, uh, and we can see something familiar with in this code. For example, private string password. This is an object and is also a variable. Also, balance overdrawn penalty, and static means it's global. Global. What is global? Uh, uh, for example, we can use we know we can use this class by bank accounts. B equals new bank account and brackets. Okay, we define the new object bank account B, and we can use B dot password, and B dot password equals ABC. We can set like this because B is the object. And for static variables, we can directly modify it. For example, this cannot be an example. This can't be an example. We define an example here. Public public static int x equals 2, and then we can just set bank account dot x equals 2, and this static this x is an static variable, but we cannot modify the password, which is not a static field here, like this. And once we modify this, we can access b dot x, and then we will get 3. I change this to 3. And also we define bank accounts, bank account C equals to new bank account, and then C.x is also 3 because I change the the static, so I change the value of x in all the classes, uh, which implement the bank account class. This is what static means. And this final means that the original penalty cannot be modified. So this is a safe definition. We don't need to worry about it will change, and it, it will also change the value in other classes, which lead to messes usually. and these are uh, functions, and these are variables, and these are all objects. Then we use a class bank account to include these all objects. Okay, let's continue. Public, private, and static. This is what we talked before. The keyword public preceding the class declaration signals that class is usable by all claim programs. If a class is not public, it can be used only by classes in its own package. How can we describe this? How can we describe this? For example, class and public class A, and then uh, and then we in then we use private and x equals to 0 and private and not private anymore, public and y equals 1, then we end this definition. Okay, then we declare an object by using the public class A equals to new A. Okay, we declare this object A equals A dot X equals to 1, A dot Y equals to 2. What will we get there? Sorry, we cannot get anything there because uh, A dot X equals to 1. This cannot be executed because X is a private object, so we cannot use it outside of the class. Public methods are also accessible to all claim programs like these variables. So this the private, public, and static. These keywords are meaningful for all the objects, not only variables. Also the data structures and functions. A static variable contains a value that is shared by all instances of the class. Static means that memory allocation happens once, and the static variable was initialized outside the constructor, and that its value can be changed. Okay, this is an example for using the class public and private and static. It is shared. So in the last example, we we modify these instances and outside, and then we can also modify init. For example, we define employee A and A equals to new employee, and then employee B equals to new employee. And then we this is a list, and we define a list 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 L list int L equals to 1, 2, 3, 4, 5, and then oh no, let me see, let me remove this. Okay, and we define the A here, define the C equals to new employee. Okay, now um, what will uh, what will we get in the we can define a function here, public public uh, void void print. Mm. And we can define a print here. We define a print here. Then, for example, system.out, and this a classical scheme, print line employee count, and then we use the print no list int lb equals to 1, 2, 3, and this is the constructor. So while defining the employee instance, we should pass the variables into these arguments. LB, then LC, L. Then we will get the 5 because the list L has 5 elements, and it and this modified the private static int employee count. Oh no, not 5, it's 3. 3 plus 5 is 8. 3 plus 5. This is there are 3 elements here because the employee count does not reinitialized, and this count from 0. Let me see. Okay, let's continue. Methods. Okay, now let's continue. And, and methods. Methods have headers. Headers access specifiers. This is an access specifier public, and the return type is void, so it doesn't return anything. And this is method name is also the we can call it a function name, and these are parameters of the arguments. And there are several types of methods in a single class: constructors, accessors, and mutators. We'll discuss these three kind of methods soon. Okay, constructors. This is an example of constructor. A class is test, and we define a function which name is the same as the class name. So it is a default constructor, and it constructs the test. So what it means, we know we create the test t equals to new test, and we insert the parameters here. So it constructs a test account with default values, and so the default values are steel ID and test ID, and we complement this here. Yeah, test equals to new test 00, and then the parameters will be set or display directly into the elements of the class. Okay, accesses. Test T1 equals to new test 1, 1. Test T2 equals to new test 1, 2. If T1 does do ID equals to T2 does do ID return. Okay, this is an example of accesses. And T T no T1 T1 is the accessor. Oh, I mispronounced the one because the one in Chinese calls E, so I just repeat the T's, and this are T1. Okay, let's continue T1, and we can access the steel ID in the T1 by this T1 accessor. Also, we can look at the definition: steel ID, test ID, score, and the T1 dot steel ID equals to 1. Also, T2 dot steel ID equals to 1. Then this expression is true, so it will return and it will end the function mutator. Mutators are these gets and sets. Get, we can define mutator type get 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 at a string and public. Oh, let me write in another place. This is the get mutators, and for the set mutator, the cemetery. So these templates, we can use these templates to implement the mutators and static methods versus instance methods. Yeah, you can review these differences after the class ends. You can use the playbacks to help you review. Okay, this is an example from the Jigs4Jigs website. Class Jig GFG, and we know this file is gfg.java because this is the main function, and then jig.jig vaibhav, and we know jig is a static, so we can call directly, and then we can print line also we call it directly. Jig object equals to new jig. This is we create an instance. This is an instance. And this is we call the instance. And these are static functions. And then also call directly. And what will we get? We will get vaibhav, and Mohit. Yeah, these are what we will get from the console for running this program. Method overloading. What are the scheme and about is, for example, these are example functions, and we use the same name identifier func, and we can do different things. For example, we can string func, no, string s equals to func x, then it will call the third, and int a equals to from x, then we will call the second function, and then we int b equals to func x, comma x, and we will call the first function. Okay, that's how the method overloading works. Then we continue. Scope. So we know how to add the access of the variables. For example, we can define the int a, and then there's a function, and then we can call a, and then if we int b, we call a int b here, and then we call b here. No, and we define a function too, and then we call b here, and we cannot do this because b is out of the scope, and after the function is executed, it returns, and then the b is out of the scope, and it will be removed from the memory or deposit. Yeah. And these are how the identifiers, how the modifiers affect the scope of the modifier of the variable. Yeah. So for example, class A, we define private A, and private and public P. Then in class B we can void P, then A dot B equals to 1, A dot A equals to 0, and this cannot be executed. This cannot be executed because A is out of the scope, and then we know public. We can access the public variables in the world, in the global scope, and then we can access the A dot B, because this is public, and we can access it by from the world. Local variables. Local variables is the variables we use within the scope, and we does not need to use any modifiers like a point a. We don't need this, and for example, int a and a plus plus a, and then a plus plus, then this a is a local variable. Loop variables. Loop variables is inside the brackets. For example, int a equals to 1, a plus plus, and output a, and then we also output a here, and then we'll get an error here because it is out of the scope, and this a is the loop variable. Okay, then there's a summary. We can read this. In general, a set of curly brackets defines a scope. In Java, we can usually access a variable as long as it was defined within the same set of brackets as the code we are writing, or within any curly brackets inside of the curly brackets where the variable was defined. Any variable defined in a class outside of any method can be used by all member methods. When a method has the same local variable as a member, this keyword can be used to reference the current class variable. For a variable to be read after the termination of a loop, it must be declared before the body of the loop. Okay, then let's talk about reference. These are examples of references. Class object. Class is the class name, the name of a class, and object is its accessor. Yeah, and we can see this is a constructor, and this is a constructor without any. Oh, okay, my Zoom crashed. Okay, my Zoom crashed just now, and we continue our discussion now. Okay, this is initialized, and then I think this is we just not usually do this because once we forget to initialize it, we will get errors, and this is hard to find, so it's just troublesome. Um, not recommend. Okay, to define a variable. class object equals to new class. This is a constructor without any parameters. Um, and we can also add parameters here once we have the need to add parameters. We usually use this, and this is alias. So if you want to copy this class, you cannot use this because it only defines an alias. So once you change the value of obj, you will modify the value in the obj2 also. So I also does I also do not recommend this. And to set a reference object equals to new class or object 2, we can set these references. Okay, the last slide. Formal and actual parameters. For example, we can define a function void function int x, and this is main void main and x equals to input. No, we do something different. Int a equals to input, and then we call the function func a. Then we end this function, this main function. Okay, the a here is the actual parameter, and the x here is the formal parameter, because the formal parameter does not mean anything. Parameters do not mean anything without passing the values. Okay, that's all of the contents today. Thanks for listening, and welcome to subscribe our YouTube channel or Bilibili channel. Thanks for watching and listening and subscribing. See you in the next issue. Bye.